Okay, this is part 2 of the Algebra 2 9 weeks review, and we're going to go ahead and start with this monster of a problem. As a heads up, you might want to have a 4-function calculator with you. You can use your phone for the review, but for the test, remember that no phones are allowed at all. So make sure you have one, okay? We start testing on Wednesday. All right, so we just covered this topic right here. We're trying to find the values of x, y, and z that will make this system true, okay? So since we don't have any multiple choice, I erased the ones we had here because I wanted to make it a little bit more difficult. We're going to go ahead and solve it using substitution. So you see I have y equals 4, and I do have a y in both of these equations, okay? Now, I'm probably going to try to use the one that only has 2 variables. So in this case, I'm going to use this one first. Because if I plug it into the second one, I'm still going to be left with x and z. So it'll be really difficult for me to figure out what each one represents. Okay, so I'm going to plug it into the first one. So let's do that first. So we're going to use this one first. It's going to be 3x plus 2, but instead of y, I'm going to plug in my 4 because y is equal to 4. Okay, and that is going to be equal to negative 25. Okay, and I'm just going to solve for x. So we have 3x, 2 times 4 is 8, so plus 8, okay, equals negative 25. Okay, I'm going to go ahead and get the x by itself, so subtract 8 from both sides, and that leaves me with 3x is equal to negative 25 minus 8 is going to give me negative 33, I believe. Okay. Okay, remember 2 negatives, we add them and just keep the sign. So 25 plus 8 is 33. They're both negative, so it's negative 33. Okay. After that, we're going to go ahead and get that x by itself by dividing. So divide both sides by 3, and that gives me x is equal to negative 11. Okay, and that is my first answer here. And so now that I have x, I'm going to go ahead and try to figure out y. To do that, I'm going to look at the second equation here because I see that this one has a z. So the only way I'm going to find z is to plug it into the one that has a z. So let's go ahead and do that. We have negative 4 times x, but x is equal to negative 11. So negative 11 goes in there, okay, plus our y. And our y again is equal to 4 because we already had that given to us. So 4 minus z. I'll go ahead and note z like that. And this is all equal to 12. Okay, so all I need to do is simplify the numbers and see what that's going to give me. So negative 4 times negative 11, two negatives multiplied gives me a positive, and that's going to be 44. Bring everything else down. So plus 4 minus z is equal to 12. Okay, 44 plus 4 is 48. Bring down that minus z again is equal to 12. And finally, we're going to solve for z. So to do that, let's go ahead and move this 48. So minus 48 minus 48. That gives me 0 on this side. And I'm left with negative z is equal to 12 minus 48. Since 12 is positive and 48 is negative, we're going to subtract it. So 48 minus 12 is 36. Okay. But since 48 is bigger than 12 and 48 is negative, it's going to be negative 36. Okay. Now you might be thinking, oh, we're done, but not quite. We still have this negative right here. So remember that there is a imaginary 1 here. We're going to divide both sides by negative 1. That'll get rid of the the negative on this side. And negative 36 divided by negative 1 is just positive 36. So there are our 3 answers. We have y, x, and z. But remember that when we're doing the solution set, we're actually writing it in order. So I'm going to go ahead and put the solution right here. Start with the parentheses, and x goes first. So I'll put a little x up here. So it's going to be negative 11, comma, y is next. So I'll put a little y up here, 4, comma, and then we have z, which is 36. So this would be our solution to this particular system of equations, okay? Just make sure that you do put them in order, because you might get the numbers, but if you put them in the wrong order, it's not going to be correct, okay? All right, let's move on to the next problem. This one says solve using substitution. So we used substitution when we did part of our zombie project. We were trying to find the intersection of at least one system in on our quarantine zone. Okay, so in this problem, it even tells you can plug in x since it's already solved. So we have that x is equal to 2y minus 10. That means that wherever I have an x, so there's an x right here, I can take all this and plug it into there. Okay, so I'm going to go ahead and do that. I'm going to take this equation, I'm going to work over here so we can see all the steps, and I'm going to plug all that into that part. So I'm going to have 3 parentheses plus 5y is equal to negative 9. And I believe I made these numbers up, so if we do get some decimals, don't freak out. It happens, okay? So this parentheses represents the x right here. So I'm going to go ahead and plug in my x. So let's make it a different color. So let's say x is 2y minus 10. So 2y minus 10. And the reason I'm doing that is because I want to get everything in terms of the same letter, so y in this case. So from here, we just simplify it. Let's go ahead and distribute. We have 3 times 2y is 6y. 3 times negative 10 is negative 30. Okay, bring down that 5y and everything else equal to negative 9. Okay, and we're just going to go ahead and solve for y. So I have 6y and I have 5y. That's a total of 11 y's. Bring down the 30 equal to negative 9. Okay, and it's just a simple two-step equation. From here, we add 30 to both sides. So plus 30 plus 30, bring everything down. So 11y is equal to, again, we have a negative and a positive, so we're going to subtract it. 30 minus 9 is 21, and the bigger sign is the one that we keep. So 30 is bigger than 9, it's positive, so it stays as positive 21. Okay. The last step is to get rid of this 11 because we want y by itself, so we're going to divide both sides by 11, and that gives us that y is equal to 21 over 11. So let's go ahead and get the calculator approximation for that. Let me do that really quickly. I see 21 divided by 11. I'm getting 1.909. So we'll just put 1.9. Okay, that's fine. So y is equal to, let's rewrite it. Y is approximately equal to 1.9. Okay, but we are not finished. We also have to have an x. So for a solution, I'm going to put that right here. We need to have an x and a y. So right now, we have the y. We know that y is equal to 1.9. Okay, but we need to find x. So I'm going to go ahead and do that by plugging into, well, the second one right here. Okay, so let's go ahead and do that. I'll put a little space right here. X equals 2 parentheses minus 10. And in that parentheses, we're going to plug in the value of y. So y was equal to 1.9. Okay, so we're going to multiply that. So x equals 2 times 1.9 is 3.8. Bring down the 10. Okay, and then we just subtract this. So 3.8 minus 10. You can use a calculator if you need to. X is going to be equal to 6.2. But again, since 10 is bigger and 10 is negative, it's going to be negative 6.2. So there is our x value. Let's go ahead and put that over here in our solution. 6.2 negative. And that's it. That is our answer for this one. Okay. The one on your exam, I believe, should be easier. I don't think there's any decimals involved, but you should have a for function just in case. Okay. Let's go ahead and move on to the next problem. We have another system of inequalities that we need to graph and shade accordingly. So let's look at each one individually. Okay, so we're going to look at this one first. Y is less than 4. So if you notice, there is no slope. So M is 0. M represents slope. Okay. The B, which is your y-intercept, well, it's the 4. It's just 4. So if there's no slope, that means that the graph is going to be, the line is just going to be across. It's going to be a horizontal line. And I also see that on the inequality, there is no equal sign. So right here, there's no equal sign. That means it's going to be dashed. Okay, so I'm going to write those things here. It's going to be dashed. And since it's less than, so less, okay, it's going to be below or down. We're going to shade down. Okay, so let's go ahead and go to our y-intercept for this is y and go to 4. 1, 2, 3, 4. Make sure 1, 2, yeah, 1, 2, 3, 4. And since there's no slope, that means that the graph is just all the way across 4. Oh, hopefully yours is a little more straight than mine. Okay, and this one is dashed, so that means that it kind of looks like this. It's not connected, but it's still a dashed line. Okay, and we're going to shade below, so it's going to be everything that's going down this way. And I'm going to do it lightly because remember that we have some more graphs to do. Okay, let's look at the next one. So now I'm looking at this one right here. This is a special case. We have x is greater than -3. So if you remember back from Algebra 1, whenever we have an equation with x, so this is kind of like an old review here. Okay, old review. When we have x equals a number on a graph, that looks like this. It's a straight line with an unidentified slope. So the slope is actually undefined. And the y-intercept, well, there's none because it goes up and down forever through one point on x. So this works similar to that. We're going to go ahead and go to the x-axis. So here's my x-axis and find -3. So 1, 2, 3. So that's right here, -3. Okay, and we're going to go ahead and just look at the inequality. So this one says greater. So in this case, because we're not dealing with uh, a typical equation, you have to think about greater as going to the right, okay? So shading to the right, because the right is positive and greater is positive. So we're going to go ahead and put a dashed line also because this one does not have an equal sign. So notice it does not have an equal sign. So from here, I'm going to have a dashed line that goes straight up and down. And again, hopefully yours is a little bit more straight than mine. And we're going to shade to the right because it's greater. So it's everything to the right. So far you can kind of see that this block right here is our solution set. Okay, but we have one more. So let's go ahead and look at that last one. And here we have y is greater than x. So we do have a slope and we do have a y-intercept. It's a little bit tricky because it's just one letter, but the slope is always the number that goes in front of x. So in this case, there's that imaginary 1. We're going to put it as 1 over 1. Okay. The slope is your number after that. So if we see we have nothing there, so that means our b is going to be 0. Okay. So it's going to start at 0 right here in the center. And again, just like the ones before, this one does not have an equal sign. So it's going to be dashed as well. And it's greater than. So greater than means we go up. So greater means up. We're going to shade up. So let's go ahead and graph this first. So since my slope is 1 over 1, I'm going to go up 1 over 1, up 1 over 1, all the way till the end. So it looks kind of like that. The other way, you're going to go the opposite. So down 1 over 1, down 1 over 1, and so forth. So it's that line through the origin, okay? And since it's dashed, you can actually kind of leave it dotted if you want, but I'm going to go ahead and dash it just a little bit. Okay. And we see that since we're shading up, that would be everything up like this, everything up this way. And you can kind of see where all the three colors mix. They all mix in this little triangle right here. Kind of like our zombie quarantine zone. It was a triangle also. Okay? However, one of the differences with this one is that this triangle does not have solid lines. So that means that if this were a zombie apocalypse, well, they would probably all get in. Okay, so again, let's hope it doesn't happen. But anyway, so this is what our graph looks like. This piece right here is called the solution set. So any number that's inside that area would be considered a solution. If it's on any of the lines, however, it would not be a solution because it's not equal to. Okay, that's about it for this problem. Let's go ahead and move on. The rest of the problem should not take too long. We have solution set for an equation, absolute value equation at that. So it's been a while since you've seen these, so let me run you through it. Okay. Our first step for an absolute value equation is to make sure that these two lines, the absolute value, do not have anything in front, below, or on the side. If you notice, this one has a 3, so it has a 3 right here, and it has a 2. So we need to get rid of those first, okay? The first thing you're going to want to get rid of is the 2. So I'm going to go ahead and solve that right here. We're going to subtract 2 from both sides, and that leaves me with 3, absolute value of 5 minus x. Absolute value is equal to 29 minus 2 is 27. Okay. Then we're going to go ahead and get rid of the 3. So to get rid of a 3 that's being multiplied, well, we divide. So divide both sides by 3. And that leaves me with 5 minus x, and this is all inside absolute value, is equal to 27 divided by 3 is 9. Okay, so here is where we can start actually solving. We can solve let me write that nicer. We can solve this because we have nothing in the front, so nothing here, nothing behind, nothing below. So we can solve by doing two cases, and this is where you have to do the negative positive. Okay, two cases, negative and positive. So I'm going to go ahead and do that on the side over here. Let's do our negative case first. So what we're changing for the negative is actually this last number here. So I would have 5 minus x is equal to negative 9. Okay, so I'm going to go ahead and subtract 5 from both sides because this 5 is positive, which leaves me with negative x is equal to negative 9 minus 5. They're the same sign, so we add them, so it's 14, and we keep the sign, negative 14. Okay, but we have a negative, so we have to get rid of that negative. So remember, there's a 1 here. We divide by that negative 1, and we end up with x is equal to positive 14. Okay, and that is your first answer. Now we also have to do the positive case. So for the positive case, we pretty much keep the number positive. So we're going to have 5 minus x is equal to positive 9. Okay, and we do the same step. So we subtract 5, subtract 5. I have negative x is equal to 9 minus 5 is 4. Okay, just like the one over here, we're going to divide by that negative 1 because there is a negative 1 in front of that x. And x is equal to negative 4 because 4 divided by negative 1 is negative 4. And that is about it. So our solution for this problem, and it's actually a solution set, so we put the little squigglies, is going to be negative 4, comma 14. That's it. Okay. Moving on. Let's look at the next problem. I think oh no, we still have quite a few actually. Okay, so let's look at number 14. This one is similar to this one, except that we have an inequality symbol now. So we have what's called a disjunction. Hopefully you remember that. Disjunction is the one where you have your negative and you put the symbol this way, you have your positive and you put the symbol the other way. So the negative one is the opposite, the positive one is the same. Okay, so we're going to split up the cases again. Let's do our negative on this side. So it'll be 2x plus 6 is less than negative 8. Okay, and then on the other side, we're going to do the same thing but with the positive. So 2x plus 6 is greater than positive 8. Okay, so we're going to solve. Just like we did before, we're going to subtract 6 from both sides. So 2x is less than negative 8 minus 6, same sign, so we add them, it's 14. Keep it negative, and then divide both sides by 2 to get that x by itself. So x is less than negative 14 divided by 2 is negative 7. So there is our first answer. Okay. The next one, we do the same way. So minus 6 minus 6, 2x is greater than 8 minus 6 is just 2. Divide both sides by 2. So x is greater than 2 divided by 2 is 1, not 0, 1. Okay, so our answer for this one would be that x is less than negative 7 or x is greater than 1. So be careful, because if you have the answer in the wrong format, you're going to get it wrong. Okay, so make sure that if it's greater than, that's a disjunction. So disjunctions are or statements. Okay, it's this or that. Okay, moving on. This problem, it's kind of like one we already went over, but I wanted to go ahead and just give you one more because why not? Okay, because this one has a negative. Maybe that's why I wanted to do that. So for this one, we're going to first rewrite it. It says if you transform the function f of x is equal to the absolute value of x by this rule, okay, what will the new equation be? Well, let's go ahead and call it y. So y equals, we're going to say that negative 3 goes in the front. Since my function is absolute value, you have your bar lines, and this just goes inside. In this case, we just have an x. There's nothing else in the parentheses. So this parentheses right here, there's nothing else in there, okay? And then plus 2 goes on the outside. So that means, according to this, okay, that our vertex is going to be, well, it's going to be 0 because there's no other number here in this spot, okay, comma 2. Remember that the vertex always comes from in here and right here. Opposite, same. So it's opposite and the same. But of course, since there's nothing there, that one's just a 0, okay? And the slope is going to be negative 3 over 1. So that means I'm going to go down 3 over 1, down 3 over 1, okay? So let me go ahead and plot that. So 0, 2 is our first point. So there's 0, 2. And then from here, I'm going to go down 3 over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And the same on the other side. 1, 2, 3 over 1. 1, 2, 3 over 1. It looks something like this, which makes sense because if you remember the rules of transformations, the negative is a reflection. The 3 is a vertical stretch. That's why it looks narrower, thinner. And the 2 is 2 up. So from the center, it went up by 2. Okay. By the way, this right here would be a maximum, just in case you forgot. Okay. And that's about it. So moving on, we have our last two word problems. We know how much you all love word problems. Okay. So this first one is asking you, I believe, to write a system. So let's see. Tickets for the Avenged Sevenfold concert in Albuquerque cost different for adults and senior citizens. On Friday, so on one day, we have 180 adults and 43 senior citizens. And that was a total of 15,650. Okay. So I'm going to write that as I go. So I have 180A A for adults, plus 43 senior citizens. So 43, we'll call that S, okay? And that was equal to 15650. Okay, that's a lot of money. And then we had on Saturday 175 adults. Oh, wrong color. Let's get the other color. So 175 adults. So 175A, okay, plus 25 senior citizens. So I guess the senior citizens didn't want to go on Saturday. So 25 senior citizens, okay? And that was equal to 14,375. So 14,375, okay? And then it says, write a system of equations that would be used to find the unit price for adults and senior citizens. Well, we just did that, okay? So this is the answer for the first part. That's the easy part. It should be the easy part. The next one says, what is the price for adults and senior citizens? So luckily for us, we have multiple choice. So all we're going to really have to do is plug stuff in. Okay, so here we're going to plug it in, okay, to solve. So these numbers are going, so like this number and this number would get plugged into here and here. And if it equals 15,650, well, that would be a check mark, right? And then we have to plug it into the second one here and here. And if it equals this one, well, that'd be another check mark. And if there's two check marks, what do you think that means? Well, it means it's a solution. Does this look familiar to you? It should be, because this is actually just test point, okay? So you should be an expert at this by now. We've done it so many times in class. We're using test point, guys, okay? So what I'm gonna do is I'm gonna do maybe one, maybe two. We haven't tested them yet, so I'm gonna, oh, I think I erased too much there. We haven't tested these yet, so I'm gonna get rid of those check marks because we don't know if it's true or not. But let's go ahead and try the first one, okay? So I'm gonna try A. Let's do that in red. Okay, I'm gonna try A. So I'm gonna take this system, okay, and I'm gonna work it out. So I have 180 times, well, my adults is 50, okay, plus 43. My senior citizens was 75. And I'm gonna see if that's equal to 156, I'm sorry, 15,650. So we're gonna see if this is true or not. Now, obviously, these are big numbers, so I do recommend that you get yourself a 4-function calculator, guys, because we are not going to provide that. The graphing calculator is just too easy with that one. We want you to think, okay? So 180 times 50 is 9,000. You just have to trust me on that if you don't have a calculator. And then 43 times 75 is 3225, okay? So if we add those two things, let's see, 9,000, I am using a calculator right now, 3225, okay, we get 12,225. So as you can see, this one is not equal. So this is an X. Okay, so that means that right away, I don't even have to look at the second one, because if the first one is false, well, there's no point in checking the second one. Okay, so that's how you would do this one. You should be able to go ahead and check the other ones. You plug them in the exact same way. Make sure that they are check marks for both. They have to, okay, so we can write that down. So both equations need to be true. Okay. If you have any questions about this problem, you can go ahead and ask me in class if it's still unclear to you, okay? And the last problem, finally. I know you guys are probably exhausted with all my talking, but here we go. We have that NHS sold flowers for the Halloween dance as a fundraising project. They sold a total of 90 flowers. So we have 90 flowers. Roses for 250, carnations for 275. So I'm going to write that down. So roses are 250 each. Carnations are 275 and daisies are 350. Okay, those are just the unit prices. It says that the total sale came out to 241.25. So all these together, they should add up to 241.25. Okay, so if you wanted to write this as an equation, you could do it like so. You would do 250 R, because that's how many roses, that's how much the roses are, plus 2.75 C, because that's how much our carnations cost, plus 3.50 D for daisies. And all this is supposed to add up to 241.25. Okay, so there's one possible equation. The next part says that if 55 roses were sold, so they actually told us that R is equal to 55. Okay, so this is the number of. So don't confuse it with this stuff. As a matter of fact, let's ignore that. Just go with this. Look at your equation. Okay, so the number of roses is 55, and it also says there were 30 fewer carnations than roses. Okay, so that means that our carnations is 30 fewer. Fewer means less. We're going to subtract here. So it'd be 55 minus 30, okay? And they want to know what is the amount of sales for the daisy. So they want to know how much money we made, amount of sales from the daisies. Okay, well, I mean, in this case, it's kind of like what we did on Friday, but it's a little easier because if you see, we don't really have that many variables to work with. We know what R is, we know what C is, and we know that altogether, let's see, we skipped a part. Altogether, there was 90 flowers. So that means that these three, carnations plus roses plus daisies, they all have to add up to 90, okay? So R is 55. C would be, let's see, 55 minus 30 is going to be 25. Okay, so we know R, we know C. We just have to find D. So we're going to plug these in to find D. Add them up and subtract. Okay, so let's see. That would be, let me see. First we have carnation. So let's do, for C we have 25 plus, for R we have 55. I'm going to use the different color for that. So for R, we have 55. And for D, well, we don't know what D is. D is the daisy, so that's what we're trying to find. Okay, so just go ahead and add them up. 25 plus 55, that would be, let's see, 60, 80. That's going to give us 80. So 80, so those two give me 80, plus D is equal to 90. And it should be obvious what D is equal to, but if not, it's okay. We can keep doing more math. So minus 80 to both sides. So D is equal to 90 minus 80 is 10. So there were 10 daisies sold. Okay, but if you look at the problem, they want the amount of sales. So we need to go and see how much daisies are worth. So it tells us right here, daisies are worth, sorry about that. I do not know what just happened there. Daisies are worth $3.50, okay? So we need to multiply still. Multiply 10 by 350. So 10 times 350, if you use a calculator, okay, is going to give us $35. Okay, and that's it. So the amount of sales for daisies was $35. And that's it, guys. That's it for the review for these last two videos. If you have any other questions, please let me know in class on Monday. You can also email me, and I will try to get back to you as soon as I can. Okay. Thank you for watching.